Hi, my name is Alicia Herring, and I am a kindergarten teacher at Hand in Hand in Thomas County. I would like to share with you some research that I conducted in my kindergarten classroom for students falling below math achievement in early numeracy skills. The purpose of my research was to expand on some research done by Wilson, Revkin, Cohen, and DeHane, in which they stated the need for more research on programs to enhance number sense and intervention results. Since Thomas County recently implemented an individualized Harcourt math program on the computer as an intervention for students performing in red on the Dibels Math screener, this is the focus of my study. I aim to see if students performing in red on the Dibels Math screener would have increased scores on the Dibels after using this Harcourt math intervention program. The screener should identify students with low number sense, and the Harcourt Math program is our intervention to achieve results. This research was centered around 3 questions. Is Harcourt Math an effective intervention to increase math achievement in low-performing students? Is the Dibels Math screener a valid tool to identify students with the low numeracy skills? Did students receiving instruction in the Harcourt Math program demonstrate improved achievement on their Math Dibels screener? Kindergarten students in 4 out of 16 classrooms at Hand in Hand located in Thomas County were screened for low numeracy skills with the Dibels Math screener. After being screened, students scoring in the red were considered at risk for low numeracy and math achievement. 16 students out of the 4 classrooms were identified as at risk for low numeracy skills. These students were then selected to work on the individualized Harcourt Math program 3 times a week and were progress monitored every 2 weeks to see if they would have a gain in their scores. The Dibels Math screener was used to assess all kindergarten students for low numeracy skills. The Dibels Math program consists of 3 separate tests: beginning quantity discrimination, number identification, and next number fluency. Each section of the test is timed with students having 1 minute to answer as many questions correctly as possible. All students are screened, and students scoring below the 20th percentile are the ones considered at risk for the low numeracy skills. Data was collected and analyzed with 3 separate t-tests for 2 different groups. Group 1 was the students that were considered at risk for the low numeracy skills, falling below the 20th percentile, and Group 2 was students performing on grade level or above in math. The identified students in Group 1 worked on the individualized Harcourt Math program 3 days a week for 20 minutes a day. They were progress monitored every 2 weeks to see if they were making gains in their numeracy skills. Students from the same 4 classrooms not identified as at risk, this is Group 2, and did not receive the Harcourt instruction were compared using the t-test as the same t-test as the students receiving the intervention. Both groups were given the same pre- and post-test benchmark test using the screener in all 3 areas of next number fluency, number identification, and quantity discrimination to determine the scores. Students in the intervention program, or Group 1, showed a 6% to 31% gain in number identification. They showed a 19% to 25% gain in next number fluency, and they showed a 0% to 44% gain in quantity discrimination. Based on these results, the Harcourt Math program is effective to increase math achievement in low-performing students in all 3 of the identified areas. The paired sample t-test for next number fluency showed scores for 16 of the students before and after this program. There was an increase in performance after using Harcourt Math in number fluency. The mean was 7.56. And then before the program, the mean was 5.06. This indicates the program had a positive effect and is significant because the p-value was 0.02, indicating a real difference in scores not obtained by chance. For a number identification, the paired sample t-test shows scores for the same 16 students before and after the program. There was an increase in performance after the program, with their mean being 11.81, than before the program with a mean of 4.62. This also indicates the program had a positive effect and is significant because the p-value was 0.04, less than the 0.05, indicating a real difference in scores. The paired sample t-test for quantity discrimination shows the same results. There was an increase in performance after using the Hardcore Math program with a mean of 6 than before the program with a mean of 2.13, indicating it had a positive effect and is significant because the p-value is 0.011, less than the 0.05, indicating a real difference in scores that was not obtained by chance. When we look at Group 2, the students that were performing on or above grade level in the three areas, we see they had an increase from 31% to 63% in number identification. They had an increase of 46 to 63% in next number fluency, and they experienced an increase from 34 to 54 in quantity discrimination. But when you compare these students with using the same t-test that I used for Group 1, the results become even more valid. The paired t-test for this group of students with number identification had a beginning benchmark compared to the ending benchmark, showing an increase in the ending benchmark of 20.4 than before the benchmark of 10.75. However, the t-test shows that is not a significant difference between the before and after benchmark scores, indicating there was too much left to chance, because the p-value is 2.68, which is far greater than the 0.05. Also, the same paired sample t-test for next number fluency with the beginning benchmark compared to the ending benchmark shows the mean of 10.83 in the ending benchmark and 8.48 in the beginning, which is an increase, but however not a significant difference between the before and after, indicating too much was left to chance, as the p-value in this one was 2.24, greater than the 0.05. Again, with the likelihood of regular classroom instruction and not a specific program, as there was too much left to chance. The same shows true for the quantity discrimination t-test, with a beginning benchmark for this group compared to the ending benchmark. The ending benchmark was 8.54 and the beginning benchmark was 6.04. But again, this is not a significant difference between the before and after, indicating too much left to chance, with a p-value of 7.5, which is far greater than the 0.05. When we compare Group 1 and Group 2 to see their percentage increases, Group 1 experienced a 416% increase from their beginning benchmark to their ending benchmark, while Group 1 experienced a 103% increase. In next number fluency, Group 1 experienced a 31.5% increase in scores, and Group 2 a 37% increase in scores. For quantity discrimination, Group 1 experienced a 4,400% increase in their scores, while Group 2 only experienced a 59% increase from their scores. When we compare the students this way, Group 1 performing below grade level in math and Group 2 performing above grade level in math, this study teases out other factors that may influence the gains of student scores before and after the program. While teacher instruction did increase the mean scores in all three areas of the Dibels Math screener, the next number fluency, the number identification, and the quantity discrimination, the t-test results for Group 2 shows classroom instruction, time effects, maybe pre or post-test, or other factors likely to be the cause for the increase in their scores. Too much was left to chance for them. While Group 1's results show the Hardcore Math intervention program itself to be the cause for the increase in scores of all three areas on the Math Dibbles screener. The summary of the results. The Dibels Math Screener is directly aligned to the Common Core Georgia Performance Standards, and it seems to be a valid tool for identifying students with low numeracy skills, as it targeted 16 out of 16 students performing below grade level on the math standards in the total of all 4 classrooms. From the teacher's perspective, the 2 students that were not performing below grade level but were caught on the math Dibels as having low math skills were distracted by the timer and did fine on the next benchmark. Based on the results of my research, hardcore math is an effective intervention to increase math achievement in low-performing students in all 3 areas on the Dibels Math Screener. Quantity discrimination showed the biggest gains in achievement, and students in the regular instruction program did show gains, but the increase in gains was more significant among students in the intervention program, with the exception of maybe next number fluency. In conclusion, the findings from the study support the research by Chang and Slavon in 2012, which shows the need for better tools to increase math achievement in young children. As stated by Charlesworth and Lalo 2011, young children spend most of their time learning through play. They further state that teachers need to be on the lookout for math and play to support children's natural learning style. Teacher-selected individual and small group adult-guided instruction can be effective if it is game-like, challenging, and fun. Educators are now paying special attention to computer games as a tool for enhancing math achievement. And studies researched by Kim and Chang in 2010 support the idea that games have a positive effect on learning when the game is built in to support learning skills. All of this research is supported by my results from the Harcourt Math program as being an effective computer game to enhance math achievement. As we look into the future and look at some limitations of this study, a limitation for the research that I conducted was the small sample size and the short time frame. While the t-test seemed to limit the likelihood of chance being the cause for the increase in math scores with Group 1, I'm still not assured it was solely the hardcore math program and not just the extra attention given by the teachers to those students. I think it would be interesting to conduct this same research with another math intervention program to see if the same results are achieved. Still, the study does show positive results when using this hardcore math program as an intervention with the at-risk students, so I definitely think it's a valid resource to increase low numeracy skills in at-risk students on the Dibels Math. And also, the Dibels Math Screener does seem to be a valid tool to identify those students at risk for low numeracy skills. It did catch a couple who were not performing below grade level in math, but again, the teachers state that was the time and not the actual screener itself. This was a pilot year for the Math Dibels program, so future research should be conducted to continue the validation of this tool for identification of those students performing below grade level in math. Future research should also be conducted to analyze the predictive validity of Dibels math measures to the statewide assessment of math proficiency. Thank you for your time, and I hope you enjoy the research results of this study.